Okay, so today I'm going to show you how we are going to be transferring the water in the speaker. I'm going to be transferring the water in the speaker into this speaker using a piece of blue yarn. Okay, so this blue yarn has been sitting in the speaker of water for about 3 minutes, right? Okay, 4 minutes, and we're going to transfer the water contents in this beaker to that beaker using this piece of blue yarn. Okay, so Noah, I'm going to have you hold it right above, directly the center of that beaker. Okay, just hold it there. Oops, sorry. Okay, ready? Okay, so the water is going to be traveling along the yarn into that beaker. You may want to get a little bit closer so you can see the water traveling. See the water traveling? Because the water is attracted to the yarn by adhesion, and water is traveling with water by cohesion. So this is an example of capillary action where water moves together by adhesion and cohesion. So yeah, all of this water could be transferred over to the other beakers simply by using a yarn. And we won't do that though. My arms are getting a bit tired. So, but you guys get the idea, right? Capillary action, cohesion, and adhesion. Thank you, Noah, for being my partner.
Thank you.
Okay, so we've been talking about cohesion and adhesion. Those are two properties of water. Remember, cohesion is where water is attracted to water, so that's why water tends to stick to water, and then adhesion is where water sticks to anything that has a charge, because water is polar, right? Water has a positive and negative end, and so it will be attracted to anything else that has a charge on it, okay? So what I wanted to demonstrate here, okay, I have 2 microscope slides that I've taped together. I don't know if you can see that, but these are 2 microscope slides that I've taped together on one end. It's kind of hard to see there. Okay, so there's the tape, and there's a little bit of a gap in between the glass slides. Okay, there's a little bit of gap. And so if there's a little bit of gap, water should be able to move through in between the glass slides. So glass and plastic, a lot of substances have charges on them. So water should be attracted to this glass, okay? And I have some blue food coloring, which is mostly water. So what I'm gonna do is I'm going to, on this plate, I'm gonna put a few drops of blue food coloring. Okay, so the blue food coloring is mostly water, okay? So it's mostly a polar substance. And I'm gonna go ahead and take the 2 slides that are taped together and dip it into the food coloring, and let's see what happens, okay? So what do you guys see there? What's happening here, right? Oops, there's a reflection there. But as you can see, the food coloring is moving up the glass in between the space in between the 2 pieces of glass, okay? So this is an example of cohesion and adhesion. I apologize for the reflection there. There we go, that's a little bit better. This is an example of capillary action, okay? Where water is attracted to the glass by adhesion, and then water is attracted to each other, pulling each other up by cohesion, okay? And so this is how a lot of plants will bring water upwards from the roots to the leaves. Look at the blue food coloring has already reached the top, okay? That was really quick. So this is an example of capillary action. This is how plants move water from their roots all the way to the top of their leaves. And as you know, some trees are several hundred feet tall. So by capillary action, water moves up. Okay? All right.